Hello students, in this class we will do some problems. We will do 5 problems on complex numbers from Jee Mains 2021. So in each problem I am going to explain the concept also, so it's better to watch till to the end. Okay, I'll explain the concept as well as how to solve the problems. Now you see, here we have the first question. Let the lines, so what is the first line given here? 2 minus I into z is equals to 2 plus I into z bar. Okay, so equation of the line given in terms of complex numbers. Now if you are confusing with the complex numbers, simply you can convert this into Cartesian form. Okay, so now how we will convert this? So we write now first 2 plus I by 2 minus I. Okay, so taking this 2 minus I dividing with the 2 minus I on both sides, you get this, which is equal to z by z bar. Okay, now just you apply componendo dividendo. You know, componendo dividendo is what? A by B is equal to C by D. If you have A plus B by A minus B, okay, A plus B by A minus B is equals to, what is that? C plus D by C minus D. Simply you can say like this: numerator plus denominator divided by numerator minus denominator on both sides. Numerator plus denominator by numerator minus denominator on both sides. So here we have numerator is 2 plus I plus denominator is 2 minus I divided by numerator is 2 plus I and denominator is 2 minus I. The same thing in right hand side, numerator plus denominator z plus z bar by z minus z bar, right? So now you see, after simplification what you are going to get? 4, and here we have, what is that? I cancelled, and here minus I, what we did here, 2 plus I numerator plus denominator by numerator minus denominator. We have to do here numerator minus denominator, sorry for this, you will get plus I. Okay, so now minus 2 plus 2 cancel, you get 4 by 2i. 4 by 2i, which is nothing but 2 by I, which is equal to z plus z bar. Now this is very important formula from the complex number. Listen carefully. Z is equal to, if you have x plus iy, okay, you have to keep this in mind. It's a very important rule. Z bar is equal to x minus iy. Okay, its conjugate z and its conjugate z bar is x minus iy. Now if you add these two, what will happen? Z plus z bar is equals to 2 into x. What is that? Z plus z bar is equals to 2 into x means real part of z. Okay, we write in short form re of z, real part of z. So this is, you have to remember, z plus z bar is equal to 2 into real part of z. Very useful formula. Also, if you subtract z minus z bar is equal to, you will get 2iy. So what is the z minus z bar is equals to 2i imaginary part of z, 2i imaginary part of z. So most of the times we use this, okay, imaginary part of z. Whenever you want imaginary part of z, we write simply z minus z bar by 2i, if you want imaginary part of z. And if you want real part of z, we write z plus z bar by 2. Okay, so now all these things you must know, right? So if you don't know the basics of complex number, already I made some videos on basics of complex numbers. There is a playlist of basics of complex numbers. You can watch it to understand the basics, right? So now what I just now I told you, z plus z bar is what? 2 real part of z. Okay, I'm writing that directly, 2 real part of z. Z minus z bar is what? 2i imaginary part of z. Okay, now 2 you can cancel here, I you can cancel. Now if I suppose z is equal to x plus iy, what is the real part? X. What is the imaginary part? Y. Yes or no? So 1 is equals to, real part of z is x, and 2 into imaginary part of z is how much? Y. So what you got here? X is equals to 2y. You know, so this is the line what he says. 2 minus I into z is equal to 2 plus I into z bar is a one line given by what? X is equal to 2y. Now similarly you see the second one. One more line is given. What is one more line? So here these two lines, okay, these two lines are what actually normals to a particular circle. There is a circle. For this circle, these two lines are normal. You know normal always passes through the center of the circle. Normal always passes through the center of the circle. So if I say here we have a center, if you want to draw a tangent line, first you draw, if you want to draw a normal, first you draw a tangent line, then if you draw a normal, it passes through the center of the circle. So it is given that two normals, okay, here two normals given to you. If two normals given, just if you solve them, you will get the center of the circle. You know, the point of intersection of normals is what? Center of the circle. So here with the help of these two normals, you can find out center of the circle. Okay, now let's see the second line. Second normal is what? 2 plus I into z. What is that? 2 plus I into z plus I minus 2 into z. If I take 2 common, what I get? 2 into z, okay, minus 2 into z bar. So 2 into z minus z bar. If I take I common, z iz plus iz bar plus iz bar minus 4i is equals to 0. Now you see here. Once again, z minus z bar is what? 2i imaginary part of z. So I use it again, once again, 2iy plus I into z plus z bar is what? Z plus z bar, 2 real part of z, right? Real part of z is what? X. So 2x minus 4i is equal to 0. So here you have I common as well as 2 common. If you take 2i common, what do you get? X, 2i common plus 2i, then what do you get? If you take 2i common, x plus 2y minus 2 is equals to 0. Correct? So x plus 2y minus 2 is equal to 0. This is the second line we got. X plus 2y minus 2 is equals to 0. Second normal, right? So one normal is here. We have x is equal to 2y, and the second normal is here. We have x plus 2y minus 2 equal to 0. If I solve these two equations, if I solve them, what I get? Point of intersection of the normals, which is nothing but the center of the circle. So now you see here, x is equal to 2y you have. Just simply substitute that x equal to 2y here. So you get 4y is equals to 2, which implies y is equal to 1 by 2. Now if I substitute y is equal to 1 by 2 here, you get x is equal to 1. So therefore 1 comma 1 by 2 is the center of the circle. This is the center of the circle here we have. Okay. Now after getting center of the circle, you see this iz plus z bar plus 1 plus I is a tangent line. So once again you have to convert this into the Cartesian form. So do one thing, I in place of z you write x plus iy plus z bar is what? X minus iy plus 1 plus I is equal to 0. Now a complex number is 0 means its real part is 0 as well as imaginary part is 0. So what is the imaginary part? Here you get ix, and here we have minus iy, and here we have plus I. Means if I take I common, I will get x minus y plus 1 equal to 0. So this is by taking imaginary part is 0, I got the line equation in Cartesian form. If you want, you can take real part also. Okay, so x minus y plus 1 equal to 0 is the tangent line. Now you know the tangent line, yes or no? This is the tangent line. What is that? X minus y plus 1 is equal to 0, and I know the center C. And the question is, what is the radius of the circle? What is the radius of the circle? Distance from center of the circle to the line. Okay, if you find the distance from center of the circle to the tangent line, that gives you the radius r. So now how you will find center? From the center, what is the center? Here we have 1 comma 1 by 2. So 1 comma 1 by 2. From 1 comma 1 by 2, you have to find out the distance to this line. So what is that? Modulus of, you know, I'm expecting that you know this formula. So modulus of, what is that? X value 1 minus ax1 plus by1 plus c by root of a square plus b square. That is the formula you have. 1 minus 1 by 2 plus 1 by root of a square plus b square. You do a means x coefficient, b means y coefficient. You get 1 plus 1. So here we have 2 plus 1. How much you get? 2 plus 2, 4 minus 1, 3 by 2 root 2 you are going to get. So this is the radius of the circle. Okay. So in this, the key points of the problem, okay, what is expected to remember from this problem is z plus z bar is what? Z plus z bar is 2 real part of z. Okay, you must know this. And the second one, z minus z bar is equal to 2i imaginary part of z. 2i imaginary part of z. Okay, so I used this and this. Otherwise, simply you can substitute in place of z is equal to x plus iy. You multiply and compare, then also you will get the Cartesian form. Okay, right. Now let's see the second one. So here you see, let S1 comma S2 and S3 be the three sets. Okay, now S1 is defined as z is a complex number such that modulus of z minus 1 is less than or equal to root 2. Okay, so what this S1 represent, now we have to see. Okay, modulus of z minus 1 is less than or equal to root 2. If you know, it is one of the standard form. Okay, now this is a different one. Real part of 1 minus I into z is greater than or equal to 1. This is the second set, and the third set is imaginary part of z is less than or equal to 1, which is a very simple one. Okay, now let's see first S3, because they're very simple. If I suppose z is equal to x plus iy, if I suppose z is equal to x plus iy, what happens? Imaginary part of z. What is the imaginary part of z here? Y, right? So this S3 is nothing but is a region satisfied by simple condition y is less than or equal to 1. This is S3. S3 what? Y less than or equal to 1. Because of imaginary part of z is what? Y. So y is less than or equal to 1 is S3. That is the region. Now we'll see S1, S2 also. Now before going to S1 and S2, and at the end what you have to find? Okay, what you have to find here? S1 intersection S2 intersection S3. So the common region of S1, S2, S3 contains how many elements? Is a singleton set, or it contains infinitely many, has 3 elements in it, or it has exactly 2 elements? That you have to check now. Now before going to explain this S1, okay, now I'll tell you first this one, the standard form. Modulus of z minus z naught is equal to r. You know, modulus of z minus z naught is equal to r is what? Is a circle. This is a circle equation in complex numbers. Modulus of z minus z naught is equal to r. Now if it is a circle, you must know what is the center, right? The center of the circle is here. We have z naught. This is the center of the circle, and the radius is what? R. The right hand side number is what? Radius. So modulus of z minus z naught is what? Modulus of z minus z naught is equal to r represents what? A circle. So instead of equal symbol, if I write modulus of z minus z naught is less than or equal to r, means it represent the area inside the circle. Okay, it represents the area inside the circle. Is equal to r is a circle, less than or equal to r inside the circle, greater than or equal to r outside the circle. Now can you see what is this one now? Can you see? If you know this, you can identify this easily. Modulus of z minus 1 is less than or equal to root 2 is clearly in the form of modulus of z minus z naught is less than or equal to r. So what is this now? Can you tell me now? S1, what it represent? S1 represents a circle whose center represents a circle whose center is what? Z minus Z naught. This is Z naught, means 1. 1 means, how we treat 1 in a complex number? 1 plus I into 0 means 1 comma 0. Yes or no? 1 comma 0 is the center, and what is the radius? Can you tell me what is the radius? Radius is the right hand side number. What is that? Root 2. So radius is root 2. So this is S1. Now what about S2? So we have to do little bit of work here for S2. S2 here 1 minus I into Z, and you have to collect its real part. Re means real part of this number, real part of this number. Okay, so 1 minus I into Z. What is Z? We supposed here x plus iy, x plus iy. Now from this you have to collect only real part. Can you tell me how you get real part? Whenever you multiply 1 with x, you will get real part, that is the x real part. And if you multiply with 1 iy, it's an imaginary part because of I is there. Now whenever you multiply ix, that is also imaginary part, but whenever you multiply this I into iy, you get I square y. So that is plus, I square is minus 1, so minus into minus plus y. Okay, x plus y, you get x plus y. X plus y is what? Greater than or equal to 1. Okay, so here we get x plus y is greater than or equals to 1. Right, so this is your S2. This is S2. Now you see here S3 is y is less than or equal to 1. S1 is the circle, right, with the center at 1 comma 0 and radius is root 2, and x plus y is greater than or equal to 1 is a line. Now the common region of all these three, S1, S2, S3, how to do that? Let's suppose here we have coordinate system x-axis and y-axis. First, y is what is first? I will draw the circle. Center is 1 comma 0, radius is root 2. So let us suppose here we have 1 comma 0, center of the circle. So here to here the distance is how much? 1 unit, but radius is how much? Root 2. So little bit more, root 2, 1.414, something like that. So let's suppose here we have the circle whose center is at 1 comma 0. So little bit difficult to draw the circle using a digital pen, so adjust with this. So this is the circle with center at 1 comma 0, radius is root 2. Okay, now next one, y is less than or equal to 1. You know what is y is equal to 1? Y is equal to 1 is a straight line parallel to x-axis. Imaginary part of z is less than or equal to 1, y is less than or equal to 1 is a line parallel to what? X-axis. Y is equals to 1. But here we have y less than or equal. Y is equal to 1, where we have to draw y is equal to 1 is a line parallel to x-axis at a distance of 1 unit. Okay, so where is 1 here? Outside of the circle or inside of the circle? How to know that? Just what is the equation of the circle? Can you tell me? Center is 1 comma 0, therefore x minus 1 whole square plus y square is equal to root 2 square. That is the equation of the circle. Now where it meets y-axis? How to find where it meets y-axis? Simply you substitute x is equal to 0. If you substitute x is equal to 0, you know what happens? You will get y square is equal to x equal to 0, means here you get 1, 2 minus 1, 1. So y is equal to plus or minus 1. So the circle meets exactly at 1 and at a minus 1 here. So now where is the y is equal to 1 line? This is the line y is equal to 1. This is the line y is equal to 1. Now you know what is the meaning of y less than or equal to 1? Below the line. The region is below the line. Okay, we'll shade it later. Next, what is the third line? X plus y is greater than or equal to 1. So x plus y greater than or equal to 1 means x plus y is equal to 1 line first you have to draw. What is x plus y is equal to 1? It passes through 1 comma 0 and 0 comma 1. So that line will go like this. X plus y is equals to 1. This is x plus y equal to 1. Okay. Now common region. Where is the common region? Now one region is below this line. Okay. One region is below this line. And one region is what? Inside the circle. Okay, inside the circle, modulus of z minus 1 is less than or equal to root 2 inside the circle, and below this line inside the circle. And what is this represent? X plus y is greater than or equal to 1. What this represent? So we'll do one thing. I'll use different colors for this. So below this, okay, one region is below this. Here we have below this. Below this, and the second region is what? Inside the circle we must have. So this is the region inside the circle, this is the region inside the circle, okay, inside the circle, and we want below the line. So this portion we don't want, this is we don't want, so below this line we want. So therefore third one is what? X plus y greater than or equal to 1. Now how to represent this x plus y greater than or equal to 1? Do you know? Now you see, a line divides the plane into two parts. One is above the line, one is below the line. Okay, the line divides the plane into what? Two parts. One is here, one side is this, the other side of that is this. So one is, you can say, above the line, and one you see below the line, or you can say right of the line or left of the line. Okay. Now this equation x plus y greater than or equal to 1 represent which side? This side or this side? How to know that? Okay. Now simple example is the simple thing is this. Just you substitute any point, you know. For example, origin, if I substitute in this, you substitute origin in this, what will happen? 0 plus 0 is greater than or equal to 1. Yes or no? So 0 which is greater than or equal to 1 is true or false? 0 is greater than or equal to 1 is false. So therefore the region is not this side, the region is not this side, the region is this side, means above the line. So therefore this is the region x plus y greater than or equal to 1 represent. Okay. Now what you want, tell me? We want below this line, the region below this line, and we want inside the circle, and we want above this line, below this line, and inside the circle. Can you tell me where is that region? So here, if you see, this is the region what I am shading now, which is above the line, yes or no, and below the circle. This is what? Above the line, inside the circle, and below the line and above the line. Above this line, below this line, and inside the circle. So here you have how many points in this region? Infinitely many points. Okay, here in this region we have infinitely many points, so therefore it has infinitely many points, which is the third option. Okay, I hope clear this is. Okay, now let's see the third question. So now you see the third question is, Z and W are two complex numbers such that modulus of ZW is equal to 1. And argument of Z, what is given? Argument of Z minus argument of W is equal to what? 3 pi by 2. Okay. And we need to find argument of this complex number. Argument of this complex number we have to find out. Now, how to find out argument of a complex number? That basic you should know, and I made a video on how to find out argument of a complex number. How to find principal argument of a complex number, I made a video on that. If you want, you can see that video if you don't know how to find. Okay, otherwise it is difficult to understand here. Now, argument of Z minus argument of W is equal to 3 pi by 2 given. What I suppose here, argument of W, let us suppose something alpha. Then what is argument of Z? Argument of Z will be equal to 3 pi by 2 plus alpha. Okay, if I suppose argument of W is alpha, then argument of 3 pi by 2 is going to be what? Argument of Z is going to be what? Argument of Z is going to be 3 pi by 2 plus alpha. Now Euler form. Every complex number can be written as in the form of e to the power of r into e to the power of I theta. Every complex number can be expressed as r into e to the power of I theta. What is r? Its modulus. What is theta? Its argument. Okay, r we use, which is the modulus of the complex number. Theta we use, which is the argument of the complex number. So now I want to write this Z and W using that form. Okay, what is the Euler form? So what is Z? Z is equal to its modulus, mod Z, that is nothing but r e to the power of I theta. Theta means what? Argument of the complex number. Whose argument? Argument of Z. Now what is argument of Z? Here we have 3 pi by 2 plus alpha. So copy that, 3 pi by 2 plus alpha. Now what is W? W is equal to mod W. Okay, its modulus e to the power of I. Argument of W here we have to write. So what is the argument of W? We suppose here alpha. So what I do here, I'll write alpha. So W is equal to mod W into e to the power of I alpha. Now you check argument of what complex number we want to find here. Argument of Z bar W is there. Here also you have Z bar W, right? So first we calculate this part, Z bar W. Z bar W. What is Z bar? Conjugate of this. Now how to find conjugate of this? Mod Z bar is mod Z only, because of every real number conjugate is itself, and e to the power of, we replace I by minus I to get the conjugate. So e power minus I into 3 pi by 2 plus alpha. This is Z bar into, what we have, Z bar into W. Now what is W? Mod W into e to the power of I alpha. Now you tell me here, mod Z into mod W. What is that mod Z into mod W? Mod ZW, which is already given as 1. So mod Z into mod W will be equal to 1 into e to the power of, bases same, power should be added. So what do you get here? This I alpha will be cancelled with this minus I alpha, right? I alpha and minus I alpha will be cancelled. You get e to the power of minus I 3 pi by 2. Now what is e power I theta? You know, what is e power I theta? Cos theta plus I sin theta. Cos theta plus I sin theta. So what is e power minus I 3 pi by 2? You get minus here. If I write minus I theta, you get minus here. So cos 3 pi by 2 minus I sin 3 pi by 2. Cos 3 pi by 2 is 0 and sin 3 pi by 2 is how much? Minus 1. So at the end you are going to get I. Okay, you know, cos 3 pi by 2 minus I sin 3 pi by 2. Cos 3 pi by 2 is 0 minus I sin 3 pi by 2 is minus 1. So you get I. So what is Z bar W? z bar w value is I. Understood? Z bar w value is how much? Y. Now this we will see. What is that? 1 minus 2 z bar w divided by 1 plus 3 z bar w. But z bar w is I we got. So 1 minus 2i by 1 plus 3i. Now you convert this into one single complex number by multiplying with its conjugate. So if you multiply like this, 1 minus 3i, you get minus 2i plus 6i square, which is minus 6, divided by you get 10 here. So 1 minus 6 minus 5 minus 5i by 10. Okay. Now how to find out the argument of this complex number? So first we will find alpha, which is tan inverse of mod y by x. This I am not going to explain. If you want, you can see tan inverse of the previous video already I made on that. So tan inverse, how much you get? You know, tan inverse of y by x minus 5 by minus 5, you get 1. So, but tan inverse of 1 is what? Pi by 4. Now this minus 5 minus 5, if you take here common, if you want, you can, sorry, minus 5 you can take common here. How much you get? 1 plus I by 10, which is 5 by 2. So minus 1 by 2 minus I by 2, which is in the third quadrant. You know, minus 1 by 2 comma minus 1 by 2 is in the third quadrant, and in the third quadrant argument formula is minus of pi minus alpha. To find principal argument, this is formula, minus of pi minus alpha. You know, alpha for the first quadrant, second quadrant pi minus alpha, third quadrant minus of pi minus alpha, and fourth quadrant is minus alpha. So minus of pi minus alpha, minus of pi minus alpha is how much you got? Pi by 4. So minus of minus pi by 4, which is how much? 4 pi minus pi minus 3 pi by 4. So that we have minus 3 pi by 4. Okay, now we see the problem on locus of a complex number. So the condition is what? Argument of z minus 1 by z plus 1 is equal to pi by 4. I will tell you what is the meaning of argument of z minus 1 by z plus 1. What is the meaning of this? The angle between the lines, joining what? Z and 1, z and minus 1. The angle between the lines joining z and 1 and z and minus 1. That is the meaning of argument of z minus 1 by z plus 1. Now let's see. Here we have the line. This point we will suppose as minus 1 comma 0, and this one we will suppose as 1 comma 0. Can you observe? These are both are on x-axis. Okay, but in complex number we can say that is a real axis, not x-axis. Okay, so if you want more clearly, you can say it is a real axis, and the plane we call it as what? Argon plane. So minus 1 comma 0 and 1 comma 0, these are the 2 points given to you. Now z is, okay, z is what? A moving complex number, moving point. So here what I do, let's suppose here I have the complex number z. Now if I join this z with the point minus 1 comma 0 and 1 comma 0, this angle represents angle between the two lines, z minus 1 and z plus 1. This is given as pi by 4. This is given as pi by 4. What is the meaning of argument of z minus 1 by z plus 1 equals to pi by 4 is what? The angle between these two lines. Now you know, let's see, I'll remove all this. Okay, now the angle made by this segment minus 1 0 to 1 0, say this is, I call it as A and I call it as B. The angle made by this line segment AB at any moving point, okay, for example here you take, or here you take, or here you take, the angle must be what? The angle must be pi by 4. You know where it happens like this? Okay, can you guess where it happens like this? The angle made by a line segment is always fixed. This happens in the, can you tell me? Circle, right? The angle made by a chord of the circle in one side of the arc is always fixed. That we know, right? If we have a circle, sorry, if you have a circle and let's say there is a chord, if it take this angle or this angle or this angle is always same. So that is fixed here, which is what? Pi by 4, right? So now Argument of z minus 1 by z plus 1 is equal to pi by 4 means the moving point z, at that moving point z, the angle is pi by 4 made by the line segment AB. So it's on the circle. Z is moving on the circle, that you have to understand. Let us suppose here we have a circle. On this circle z is moving. So we have to find out what is the locus of z, nothing but this circle. Means you have to find out equation of this circle. Equation of the circle. Okay. Now if you connect this point with the 1 comma 0 and minus 1 comma 0, the angle made by that is how much? Pi by 4. But let us suppose here we have a center. Then what is the angle made by this line segment at the center? You know the property? The angle made by a chord of the circle at a point on the circumference is half of this. So this angle, if I say this angle is pi by 4, double to this is how much? Pi by 2. So this angle is pi by 2. So therefore angle made by the line AB or chord AB at the center of the circle is 90 degrees. Means if at the center of the circle is C, CA is perpendicular to CB. That we can conclude. CA is perpendicular to CB. Now one more thing. If I draw a line perpendicular to this chord, okay, bisecting this chord and perpendicular to this, then where it passes through? It passes to the center of the circle, right? So let's say here we have this line bisecting this and perpendicular to this, so it passes to the center. Now what is this line? Can you tell me what is this line? It is passing through midpoint of this. Now you know actually midpoint of 1 0 and minus 1 0 is 0 0. So it passes through 0 comma 0 and perpendicular to this, so therefore it is nothing but y-axis, or you can say imaginary axis. So every point on the imaginary axis, okay, y-axis or imaginary axis, what is the point on that? You can suppose that is as 0 comma k. So I supposed that point C as 0 comma k. Now can you tell me what is CA slope? Slope of CA. So a little bit of geometry we use. What is slope of CA? Okay, using a coordinate geometry concept, what is the slope of CA? Means here we have A is minus 1 comma 0 and B is 1 comma 0, right? So what is slope of CA now? y2 minus y1 k minus 0 by 0 plus 1, that is slope of CA. Now tell me what is slope of CB? What is slope of CB? So similarly we can find out k minus 0 by k minus 0 by y2 minus y1 by 0 minus 1, which is minus 1, so which is minus k. But you know here CA and CB are what? They are perpendicular to each other. So therefore product of the slopes equals to minus 1. So slope of CA into slope of CB into slope of CB is how much? Minus 1. So this implies what is slope of CA? K. What is slope of CB? Minus k, which is equal to minus 1. So if you solve it, you will get k is equal to plus or minus 1. So here actually k is equal to 1. Here 0 comma 1. So center of the circle is 0 comma 1. Now why we got here k is equal to minus 1? Now k is equal to minus 1 means the center is below x-axis, but it is not correct. Why? Because here the angle pi by 4, is acute angle. Acute angle is always formed at the point of circumference, which is a major arc. So this is the major arc, right? So the acute angle is formed in major arc and obtuse angle is formed in a minor arc. Now you may think like this. So there is a circle like this passes through the AB, and here we have. So here we have major arc. So here also you can say, sir, we will have here also pi by 4. So why not that? Because of argument of z minus 1 by z plus 1 is pi by 4, here according to rotation theorem, z plus 1 is rotated in anti-clockwise direction to form pi by 4. So here z plus 1 is this line, this one z plus 1. So this z plus 1, if you rotate in anti-clockwise direction, you will get pi by 4. But you see here z plus 1, where we have z plus 1? If you say z is moving here, this is z plus 1. Now you rotate z plus 1 in anti-clockwise. Z plus 1 you have to rotate anti-clockwise direction. So in this direction you have to move, right? So how much angle you are going to get? The amount of the rotation is not pi by 4, right? So therefore the circle is not this one. Circle is this one. Center lies above x-axis. I hope you understood this. So k is equal to 1. Therefore the center of the circle center of the circle is 0 comma 1. And what is the radius? Distance between CA. So CA, what is A here? 1 0. So the distance between CA is what? Root of 0 minus 1 whole square plus 1 minus 0 whole square, which is root 2. So therefore it is a circle with a center at 0 comma 1 and radius is what? Root 2. Okay. So here you should know the rotation theorem concept clearly. Okay. So if you don't know, I made already a video on rotation theorem. So once you see that rotation theorem, if you are unable to understand this, okay, after watching this you will understand this one very clearly. Okay, now let's solve the last problem, fifth one. See, the question is very simple actually, but just I want to tell you the importance of omega and omega square. Okay, many times the questions are framed on omega and omega square. So this is also given in the 2021 exam 4th session. So you see how we will use that omega and omega square and their properties. Here we have to find out the sum of 162th powers of these roots of this cubic polynomial. So the cubic polynomial equation is x cube minus 2x square plus 2x minus 1 is equal to 0. So every cubic polynomial has 3 roots, maybe real, maybe complex, but we have here 3 roots. Now by a simple observation, once you check here, minus 2 plus 2, can you see that? Minus 1 plus 1, can you see that? So clearly x is equal to 1 is a root of this cubic polynomial. So if you use the synthetic division, we can get the remaining 2 roots also. So if I substitute x equal to 1 in this, you can verify it's obviously a root of this equation. Okay, it's a root of this equation. Now the remaining root, synthetic division, how you will do? X cube coefficient 1, x square coefficient is minus 2, x coefficient is 2 and constant is minus 1. So first of all we write 0 here, then we add vertically. So you add this, 1 plus 0 is 1, then you multiply with this now, 1 into 1. Okay, 1 into 1 1, then again you add minus 2 plus 1 minus 1, again you multiply. So what is that? 1 into minus 1, 2 minus 1, add 1. So again 1 into 1 is 1 and at the end you get 0, which is the remainder. Now because of this is a cubic polynomial, okay, after removing this one root you will get the quadratic polynomial. So this is the coefficient of x square, 1x square and minus 1 into x and plus 1 is equal to 0. Now you should know this, x square plus x plus 1 is equal to 0, one of the important equation. X square plus x plus 1 equal to 0. The roots of these equation, this quadratic equation, are actually we call them as omega comma omega square. If you solve it, what you get? You know roots, minus 1 plus or minus root 3 I by 2. Actually here what is omega? Omega we consider as minus 1 plus I root 3 by 2 and omega square. Just I am giving the total information about this. These are very very important concepts. Cube roots of unity, very important, omega omega square. So you should know everything about this omega and omega square. So what is the omega? Minus 1 plus I root 3 by 2. What is omega square? Minus 1 minus I root 3 by 2. And omega comma omega square are roots of this equation. So you have to remember this equation. You have to identify. Whenever you see x square plus x plus 1 equal to 0, you must remember that omega comma omega square are roots of this, and omega value is this, omega square value is this, and omega cube is equal to 1 plus omega square is equal to 0. So all these things you must recollect whenever you see this equation. Okay, now what is the difference between x square minus x plus 1 and x square plus x plus 1 equal to 0? See, in x square plus x plus 1 equal to 0, simply you replace x by minus x. If you substitute in place of x minus x, what you get? Minus x whole square, which is x square, minus x plus 1. So this is the equation you get, right? If you replace x by minus x. So what are the roots of this? Roots of these are minus omega comma minus omega square. So roots of this x square minus x plus 1 minus omega and minus omega square. So we got all the 3 roots. One root is 1, the second root is minus omega, and the third root is minus omega square. Here we want to find 162th power of the roots. So means 1 to the power of 162 plus minus omega to the power of 162 plus minus omega square to the power of 162. This is the required value. 1 to the power of 162 is 1 plus minus omega to the power of 162 is omega to the power of 162 plus omega to the power of how much you get here. 163 24, so 324. Now can you see, we know the property that omega cube value is always equals to 1. Not only omega cube, omega power 6 is 1, omega power 9 is 1, omega power 3 multiple is always equals to 1. Omega power 3 multiples is always equal to 1. Now you see, this is the 3 multiple, 3 5 the 15, 12, 3 4 the, right? So this is a 3 multiple. So omega to the power of 3 multiple is how much? 1. This is also 3 multiple. So omega to the power of 3 multiple is 1. So 1 plus 1 plus 1, which is equal to 3. Okay, I hope you understood this. So here very important rules I told you about omega and omega square and equation. So once again I repeat, very important, most of the times questions are framed in this. So x square plus x plus 1 equal to 0 is a special quadratic equation whose roots are omega comma omega square, and the values of omega and omega square are what? My omega is minus 1 plus I root 3 by 2. This is expected to remember. Omega square is minus 1 minus I root 3 by 2, and what you know, omega cube is equal to 1. Not only omega cube, omega power 3 multiples is equal to 1, and 1 plus omega square. These are the properties used regularly in solving problems, this type of problems, okay, this concept related problems. Okay, so thank you for watching. If you like this video, subscribe to my channel.